Trenching is dangerous work. On average, 100 construction workers die in trench cave-ins each year. Serious injury strikes another 1,100 and permanently disables 140. Many of those killed, injured, and disabled are laborers. Making trenching safe is the contractor's responsibility. Qualified union contractors and the skilled LIUNA workforce meet this challenge every day. These contractors take a three-sided approach. Try safety. Their supervisors and laborers have training. They are skilled in the recognition of hazards, and they know how to intervene to eliminate them. But a failure to train, to recognize hazards, and to intervene can spell disaster. An unshored trench wall weighing tons can give way and crush a worker in seconds. Lives lost, families impoverished, a successful project taken to financial ruin. In real life, you can't call back mistakes and shortcuts on safety. Once done, they are forever. Sometimes cave-ins happen because a protective system is not designed or made right. But 95% of trench cave-ins happen because a protective system, such as sloping or shoring, isn't used at all. To prevent cave-ins and other trenching accidents, contractors and laborers must follow OSHA regulations. An approach used successfully by some contractors is a written site safety plan prepared before work begins. The site safety plan details hazards and control methods. A written plan makes compliance easier. Let's say you are responsible for safety on a trenching project. What do you do? What should you look for? What's in your site safety plan? Site safety planning begins long before you excavate. Let's use a checklist to consider 8 elements that OSHA requires and that would be included in a good trenching site safety plan. 1. A plan for dealing with utilities, gas, sewer, electrical, and other lines. 2. A plan for testing the air before workers enter areas where oxygen deficiency or hazardous atmospheres may exist. 3. Designation of a competent person as required by OSHA. 4. Determination of soil type. 5. Selection and design of the protective system to prevent cave-ins. 6. A plan for dealing with heavy equipment hazards. 7. A plan for emergency procedures. And 8. Training requirements for supervisors and workers. First, look at the plan for dealing with utilities. The contractor checks the area for utility lines and marks their positions accurately on blueprints. OSHA requires contractors to contact utility companies within estimated local response times. If possible, the utility companies should shut off all pipelines carrying gas, steam, water, or other materials. And the contractor must plan when and how to ground, guard, or de-energize electrical lines and cables. OSHA requires contractors to determine the exact location of all underground installations. Contractors must show workers where these lines run and train workers how to work carefully around them. Before an excavation crosses a utility line, the contractor should plan to expose the lines to show the actual elevation and alignment. Second, a plan to test the air to determine if oxygen deficiency or hazardous atmospheres may exist. To test the air, the contractor must have the right equipment. OSHA requires contractors to test the air before workers enter excavations deeper than 4 feet in areas where oxygen deficiency or a hazardous atmosphere exists or could reasonably be expected to exist. Third, the site safety plan calls for designation of a competent person as defined and required by OSHA. OSHA's excavation standard says a competent person is one who is capable of identifying existing and predictable hazards in the surroundings or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has authorization to take prompt corrective measures to eliminate them. Fourth, the site safety plan calls for determination of the type of soil. OSHA's excavation standard classifies soils into 3 basic types: Type A, Type B, and Type C. Type A soils are the most stable. Type A soils include hard compact soils such as clays and cemented soils such as caliche and hardpan, as long as the soil is not fissured or subject to traffic or other vibrations. Type B soils include angular gravel, silt, and sandy loam. Type C soils are the least stable. Type C soils include gravel and loamy sand. The fifth step is to select and design the protective system to prevent cave-ins. Responsible contractors plan how to protect workers and passers-by and how to support nearby buildings, roadways, and utilities. OSHA recognizes the following protective systems as adequate worker protection. Stable rock requires no protective system. Trenches less than 5 feet deep may require no protective system if determined by a competent person. Sloping or benching. Shield systems including trench boxes, and shoring. Shoring design and selection is done by a competent person as defined by OSHA's Construction Standard 1926.32F. Shoring varies. Examples include timber shoring with steel plates, timber shoring with screw jacks, and hydraulic shoring. The parts of timber shoring are 1. Uprights. These are vertical supports directly touching the trench's outside wall. 2. Wailers or stringers. These are horizontal wood pieces connected to uprights. And 3. Cross braces. These are struts which hold the whole framework together and prevent separation. Timber cross braces like these have cleats, and hardwood wedges take up slack. Often screw jacks provide cross bracing instead of timbers. Experts call this system of shoring with only uprights and cross braces skeleton shoring. It's usually adequate in hard, compact Type A soil. In soil likely to crack, the competent person should move uprights closer together and add wailers. In soft sandy soil or in fill, Type C soil, the competent person should add close sheeting, also called solid or tight sheeting. Even in hard compact Type A soil, the competent person may install stronger shoring than normal if the site safety plan evaluation finds lots of water in the ground. And vibration from nearby traffic or heavy equipment also requires heavier than normal shoring. The current federal OSHA excavation standard contains 3 tables listing minimum requirements for timber shoring in 3 general soil types. One table is for Type A soils, which are most stable. A second table is for Type B soils. And a third table is for Type C soils, which are least stable. As the tables show, the sizes of cross braces, wailers, and uprights depend on the type of soil, the depth of the trench, the horizontal spacing of the cross braces, the width of the trench, the horizontal spacing of the uprights, and the type of timber used. For example, let's look at the table for Type A or hard compact soil. If you're digging a trench up to 10 feet deep in hard compact soil, you can use upright shoring made of oak 2x6s spaced no more than 6 feet apart. If you want to space your uprights 8 feet apart, they must be 2x8s. Notice that OSHA does not require stringers or wailers in this soil at this depth. It does require wailers at 10 feet and deeper. 8x8s not more than 4 feet apart vertically. Let's apply OSHA's shoring requirements to another situation. Instead of hard compact soil, we have soft sandy soil or fill Type C soil. Our trench is 16 feet deep and 15 feet wide. Now 3x6 oak uprights are the minimum requirements, and this time you install close sheeting. Cross braces are 10x10s. Space them no more than 5 feet apart vertically and no more than 6 feet apart horizontally. In general, for all 3 soil types, the deeper the trench or the wider the trench, the heavier and thicker the timbers. In addition to the oak timbers used in our examples, timbers can be Douglas fir or equivalent, and separate tables exist for that wood. The standard provides similar tables for hydraulic shoring. The size and placement of hydraulic shoring also depend on the type of soil, the depth of the trench, the width of the trench, and the horizontal spacing of the uprights. Finally, the standard allows timber or hydraulic shoring designed or approved by a registered professional engineer. In large open areas with no buildings or roadways to support, you may not need shoring. Instead, you can slope the sides of trenches and excavations to the maximum allowable slope. Maximum allowable slope means the steepest incline of an excavation face that is acceptable for the most favorable site conditions as protection against cave-ins. Maximum allowable slope is expressed as the ratio of horizontal to vertical. The maximum allowable slope depends on the type of soil and the depth of the trench. In general, OSHA requires excavations to be sloped at an angle not steeper than 3/4 horizontal to 1 vertical in Type A soil. This is an angle of 53 degrees. For a trench 10 feet deep, you cut back 7.5 feet on each side at the surface. OSHA has 3 basic exceptions to this general requirement. 1, if soil is distressed and a cave-in is imminent, the slope must be cut back an additional 1/2 on the horizontal. So your maximum allowable slope would be 1 1/4 horizontal to 1 vertical in Type A soil. In this case, for a trench 10 feet deep, you cut back 12.5 feet on each side of the trench at the surface. 2 other exceptions are if your protective system is designed or approved by a registered professional engineer. This table from the current OSHA excavation standard shows the maximum allowable slopes for excavations less than 20 feet deep in different soil types. When you open a trench, the earth dries out. Cracks form. It's called air slacking. On the West Coast, some rocks, like greenish serpentines, undergo a softening change. Walls of this rock are hard and solid when excavation begins, but they soften into a slippery, dangerous mass soon after exposure to air. Contractors must shore to meet this condition. Overhangs like this are dangerous. They occur if you fail to cut trench walls vertically. If the foreman levels digging equipment, this won't happen. Here, for instance, the foreman builds a level right-of-way for the backhoe to work on. You must shore a trench as soon as possible. If you don't, the dirt walls slough off, causing overhangs which can cave in. This means good timing. Don't let the digging get too far ahead of the shoring. Site safety planning and a properly trained foreman and crew mean a smooth, continuous operation. Digging, shoring from top to bottom, laying pipe, stripping shoring from the bottom up, and backfilling. Also remember, air slacking and weather make it important to button up each day. The longer the trench is open, the more chance for a cave-in. Good site safety plans include housekeeping. Plan to lay out pipe, shoring timbers, and other equipment so they're easy to get and use, but keep them a safe distance away from the trench edge. To avoid excess weight on trench walls and to lessen the chance of loose dirt or rocks sliding into the trench, you must plan to pile excavated material, called spoil, at least 2 feet away from the edge of the trench. To meet OSHA requirements, the site safety plan must require ladders or other means of egress within 25 feet of any laborer in the trench. Check that ladders extend at least 3 feet above ground level. The regulations also require ladders to be tied off and secured at the top. Your site safety plan must allow for frequent checks of ladders to assure they remain secure and in good condition. The site safety plan should require a competent person to inspect trenches and shoring for danger signs several times daily on a regular basis. OSHA requires the first check in the morning before work and inspections as needed throughout the shift. Inspection is especially important after every rainfall. A trench is more likely to cave in after a rain than at any other time. Freezing and thawing also are dangerous. Often a trench dug in frozen ground appears safe with little or no shoring, but as work progresses, thawing may cause a section to give way. When the water table level is above the trench cut, you must pump the trench constantly. Water increases pressure on shoring, and seepage weakens it. Plan for extra shoring strength and more frequent checks. In some areas of the country, you'll use a well point system to bring the water level below the trench cut. A well point system is a series of wells drilled alongside the path of the trench to below the trench cut. A central pump pulls water at the trench location below the water table level. Trenching jobs have other dangers. For example, using boom equipment near overhead power lines. Arcing of high-tension lines can be fatal, especially to the laborer in direct contact with the equipment, the load, or the tagline. By using site safety planning, the contractor can intervene before work begins by calling the utility company to shut down or ground out the power. With unusually low overhead power lines, plan to bring in a special hydraulic crane to do the job. Working around boom equipment is dangerous in other ways you should also consider in your site safety plan. For example, the foreman must make sure that slings, hooks, and clamps are in good working order and secure, and that workers balance loads. The signalman and operator keep workers out of the way when swinging a load overhead. If equipment fails with workers in the path, they can be killed. Does your site safety plan prevent this? It's good practice to include everything in your site safety plan. For instance, training and retraining. Remember to remind workers always to walk to the side of moving equipment. When walking in front of equipment, a simple slip could be fatal. When laborers work in a trench or manhole, you need a top man. The top man checks soil, shoring, and laborers in the ditch in addition to his regular job. In some cases, the foreman is also the top man, but usually the foreman assigns another worker to the job. The top man watches what's going on in the trench. Before dumping loads or before lowering pipe or equipment into the trench, the top man, whether the foreman or a signalman, makes sure laborers below are safely out of the way. Your site safety plan should spell out emergency procedures, especially for two types of emergencies. One is a cave-in. The other is a worker who's unconscious due to gas or oxygen deficiency. OSHA requires air monitoring in areas where there may be oxygen deficiency or a hazardous atmosphere. And OSHA requires that emergency rescue equipment, such as breathing apparatus, a safety harness and line, or a basket stretcher be readily available. Let's see what can happen when these requirements are not met. While installing a storm sewer, a backhoe digging pilot holes nearby ripped open a 4-inch gas line. The crew repaired the pipe. They filled the hole. However, gas still in the surrounding earth became trapped inside the storm sewer. The next morning, no one tested the air before the workers entered the sewer. They didn't smell gas. The gas probably lost its smell passing through the ground. A flash explosion, probably triggered by a match or cigarette, claimed the life of one worker. It critically burned another, injured a third, and sent 16 rescuers to the hospital suffering from smoke inhalation. Another example. No one tested the air before a worker climbed down into a ditch or manhole. You see the worker lying unconscious at the bottom. The immediate reaction is to climb down and help. This is wrong. You have panicked. If a worker is overcome by gas, chances are the gas will overcome the rescuers too, unless they take precautions. Your site safety plan requires the foreman or top man to appoint someone to call the rescue squad or fire department. Then, to prevent an explosion, the plan requires all workers to put out cigarettes and shut down nearby equipment. Next, the plan requires rescuers to wear special equipment such as breathing apparatus and a safety harness and line. These rescuers may aid emergency response personnel once they have arrived and assessed the dangers. But under no circumstances should workers without proper equipment and training try to rescue co-workers. The site safety plan should also require worker and emergency procedures for cave-ins. Most important, after a cave-in, rescuers must stay calm. In some cave-ins, panic has killed rescue workers. Don't jump into the ditch. Cave-ins usually weaken other sections of the trench walls. You may be the next victim. Instead, the foreman or top man first tells someone to call the rescue squad. Then the foreman starts emergency shoring. There are no hard and fast rules. No two situations are exactly alike. Just remember, you must shore as you dig out. Although the shoring is only temporary, build it strong enough to do the job. Workers in trenches might be able to reduce their risks. First, you must be trained in safe practices for trenching. Second, in the trench, always be alert for danger signals. A shadow could mean a load is passing overhead. Falling or trickling sand or dirt could mean a trench wall about to fall. The sound of wood popping or metal under stress could mean shoring is giving way. You've got to be ready to act fast. The safest place is inside a pipe. If you don't have time, get against the solid wall. By holding your arms in front of you like this, you might be able to keep dirt away from your chest and create an air pocket so you can breathe. One of the most important elements of your site safety plan is training requirements. Laborers on the job in the trenches need more than just a strong back. Trenching safely requires judgment and skill. At laborers' AGC education and training fund centers like this throughout the country, laborers learn to install various kinds of shoring. They learn how to plan work, even the simplest of tasks. And they learn the all-important rule: planning equals safety, and safety equals production. Trainees learn to oil and test screw jacks to be freewheeling before bringing them to the trenching site. They learn to begin shoring from the top of the trench, and they develop teamwork. They learn that when equipment like screw jacks doesn't work, it can lead to serious accidents, and serious accidents mean lost time, equipment, and productivity. They learn to install effective cross-bracing in a level position, opened as far as possible to press firmly against the uprights. They learn how to use a cheater, a short length of pipe that gives added leverage in tightening. Working downward and by themselves, trainees learn how to install screw jacks at lower levels. They learn how to balance the jack, keep it horizontal, and screw it in place. As the trainees become familiar with the equipment, they work more efficiently, and they begin to understand how a trenching job, properly planned, can be safe. They learn by repetition, over and over, shoring from the top down and removing shoring from the bottom up. Laborer trainees also learn how to handle and maintain hydraulic shoring. These are hydraulic cross braces, and here's a situation where the laborer shores from the bottom up. Lower the hydraulic cross braces by ropes. Position them against timber uprights. Then pump open until they press outward against the trench walls. Trainees also learn how to operate hydraulic whalers. Attach the air hose, then lower the whaler to the desired depth. Level it and put a middle set of uprights into place. The laborers learn that all wood timbers used in shoring must be free of large or loose knots, splits, and cross grain. Finally, pump open the whaler to press solidly against the sides. The trainees also learn how to handle and maintain hydraulic uprights. The first lesson is a safety tip. They learn the 4 places where the shoring folds are dangerous to fingers. A plastic ballpoint pen is part of the demonstration. The instructor shows how this shoring can crush a finger in any one of these 4 places. Trainees practice what they learn about safely lifting and carrying hydraulic shoring and positioning it near the trench, ready when needed. They learn over and over the importance of inspection. Only equipment checked and tested enters the trench. Each trainee gets a chance to work the equipment. First, the trainee unfolds and sets up a section in the top of the trench. Then connects a hose from the hydraulic pump, and with a special tool lowers the unit into the trench. After leveling the crossmember, pump open the unit until it presses firmly against the trench walls. As a final step, disconnect the hydraulic hose. One laborer can install hydraulic shoring and remove it without ever entering the trench. But hydraulics can lose pressure, so you must properly install, maintain, and inspect hydraulic shoring. Trenching involves a lot of planning. The contractor plans the job. Then the foreman puts the plan in motion, keeping it progressing smoothly, on schedule, and safely. He's responsible to the crew, to the job, and to the public. But remember, the laborer has a responsibility too, a responsibility to self and family. Never to enter or work in an excavation unless it's shored properly or cut to the maximum allowable slope established by the competent person. The laborer has a responsibility not to work under swinging loads, and to be especially careful when working with boom equipment near overhead power lines. The laborer must make sure always to have direct access to a ladder, and never work in a trench without someone topside who is aware that he is there and who has a responsibility to him. The contractor, the foreman, the laborer, each knows a job planned down to detail will be a productive job. It's a rule to remember. Planning equals safety, and safety equals production. Make sure everyone on the job has training. Recognize the hazards of the work. Intervene to eliminate them. Try safety, and you'll reap the rewards: profits, production, and protection.